Okay, might try and stay a little bit focused this time. We've got an unequal Scotch Valley. It's not the same as this roof. That's 750 to 1,000, 750 rise, 1,000 run, and here we've got 1,000 rise and 750 run. Always rise to run. Uh, Here we have a sort of a fundamental rule that once we get to 1 to 1, which is 45 degrees, the rise stays at the 1 or the 1,000 and the run is adjusted. Anyway, so you can see that that's a lot steeper roof than that. What will we do? T for tape measure. I'll take that in there to half that distance. That's 1 metre. And this one here on the green, and that will go in there 1778. Okay, so I'll also bring this out to, I don't know why I insist on that being, yes I do. I set up some steel squares prior to the video. I can't do that out there because it's reliant on this. All right, so I'll hide that. I'll hide that. I'll put this as a rectangle from guide point to guide point, and I will M control. I'll just bring that out here as my point for my geometry. Now I can select back in there P for push, and I can take that up. How far? I'll take it up a bit further than normal. Take it up around about there, 8 meters. I'll get rid of that. Delete. I'll triple click on that and make that a group. And here, U for on. Here, I think we could P for push. I'll come up here. And with this one, we'll go 750 to 1,000, although this is 1,000 to 7. That's the run. That's the run. Okay. 750. I'll go this one first. So I'll come up here. 750. And we can make that. Does that look right? Oh no, that was, oh gee, out to lunch. So 1,000. Enter. Okay. And I think I'm not sure if I'm making a meal of this too. Might need to draw a line or try and pick that up. Or a tape measure line off that. Like that. To there. Is that the same slope as that? Yes. Okay. So that's got that. I'll delete that. P for push that out. And I should be able to draw a line down there. And I should be able to connect that down to there. Would have been easier to do this roof first, wouldn't it? I'm finding ways to make this difficult. I don't want to pick up stuff behind it. I could do that. Okay. That's it. Is that the same slope as that? Yes, it is. Wonderful. Okay. So I made a meal of that again too. That would have been easy to go 1,000 there, 750 rise. I don't know. maybe it was always a little bit tricky. Okay, so I've got that. So what do we do here? Nothing's changed. Nothing's changed here. What do? We take that. I'll draw in it, not on it. Put a line across there at that point. Excellent. And then we can hide this. We can hide that. Got that line across there. Double click on this. Alpha line. That triangle there is exactly the same as that triangle there. And that triangle there is exactly the same. We want the length of the hypotenuse in relation to the rise. Got that? Q. Control. Take that around there. And now our rise has gone from there to whatever it is here. And all we need to do for the calculation is get the percentage increase in this case, or last time it was decrease, that distance over the overall distance, that similar triangle stuff, and that will increase. So that's a very simple calculation. Very simple calculation. Alpha line. And that can go up to there now, and back in here then. Back in here we have that's the length of one side. Here's the length of the original true length hip for the original triangle, and that'll be a square, and this will be the triangle for that. That'll be a square angle there. This will be the bevel that we were looking for, I think. And if I go to here and click on Layboard, there it is sitting in there, just like that. That Layboard is sitting right there. I'll click off it so you can sort of see it hidden in there. But that's perfect. That's exactly what we mean. I might pause it and finish this one off just to show you how ridiculous things can be for, say, a shallow roof, but you don't need to see the process. You've seen it all. Okay, there's my layboard sitting in there. There's the square angle there. There's the bevel that I need. It's very, that's going to go way up in the air. Okay, and I've, so what I'll do around here, just for the theory part of it, once you know exactly what you're doing, you don't need this theory anymore, but you just know that it's a similar triangle with certain properties. I'll hide that. Because, and I might hide that. And I can come in here with that. That's the rise for a meter. And now we need that. I don't think I drew in that. I drew on it. I've got that selected, Q control. And there we go there. Take that around. We need to change the rise to this. So that means that this clicks on there. And that goes, oh geez. So what's the deal? You know what this length is? That's the true length of Hipple Valley for 1 metre. I might draw in it. True length valley for 1 metre. And you've got the length of that up there, which is your similar triangles theory. And back down to there. So that's a triangle that you want to develop on your steel square. It's going to be very shallow. And if I go unhide, and you can see the layboard sitting in there with that bevel that we've just developed. Again, that one's square. So the steel square would sit in there with that bevel on it, just down here, and you could use it to find that. Okay. Yeah. It's good. That understanding has helped me a lot to understand the complexities of roof bevels. I did ask AI for a little bit of help, but it gave me lots of trig. I thought I'd try and stay away from trig, so thank goodness for SketchUp I was able to nut it out with a bit of help from my AI friends. I liked it. I really liked it.